All right, so yesterday we talked about, or started talking about solutions. We know that we have three different solubilities. We can have supersaturated, saturated, and unsaturated. So remember, supersaturated means that we have too much solute per ratio for the solvent. Saturated is that perfect amount of solute to solvent, and then unsaturated means we don't have enough solute, and we still have room to add more solute. It's a very diluted or weak solution. We also have what are called concentrations of solutions, and that will give us a specific numerical value basically on how strong the ratio of solute to solvent is. So there are two different variables of concentration. We can either represent it in terms of molarity, which is the first one we're going to talk about, or the second one, which is molality. They both are going to give us similar information. It's just one deals with the solvent in terms of liters and the other one deals with the solvent in terms of kilograms. So the first one we'll talk about is molarity. So our molarity is moles of your solute over the total volume of the whole solution. So it's represented by a capital M. So molarity is the amount of your solutes over the entire volume of your solution, which we can get by looking at our solvent. And again, if it doesn't reference what our solvent is, we're just going to assume that the solvent's water. In the beginning, I'll tell you what the solvent is, but again, eventually just assume that it's always water if it doesn't reference, because that is the most common or universal solvent. So again, the one thing you need to be careful of is that the unit or the numerator is your moles of your solute, and it has to be in terms of moles, where your denominator has to be in terms of liters. So when we calculate it, you'll have two options of units. You can either have M for your unit, or your unit would be moles per liter. So either of those are acceptable because those represent what you are doing. The higher the molarity, that means the more solute that is present, meaning the stronger, the closer to supersaturated the solution is. The lower the molarity means the more diluted the solution is, meaning weaker. We're going to go through and we'll do a couple examples. So the first question asks, what is the molarity? So just make sure you're paying attention molarity versus molality. So molarity, which we know molarity is moles of solute over liters of our solvent or liters of our solution. So it's saying what is the molarity of a 0.4 or 0.5 moles of 10 liters of an NaCl solution? So we're looking here, so we know we have 0.5 moles, and that's going to be referencing our sodium chloride. So we know that we have 0.5 moles of NaCl that we're putting in the solution, and it tells us then we have 10 liters. And since it doesn't tell us what the 10 liters are, we're going to assume it's water, which makes sense most of the time when you make a salt solution, you're making salt solution with water. So we're going to go through, we need to pay attention to sig figs. So we have one sig fig here, we have one sig fig here, which means our final answer can only have one sig fig. So we're going to go through and we calculate this out, and our molarity is going to be 0.05. And again, you have two options of units. You can either put moles per liter, or you can put just a capital M of an NaCl solution. So that's a pretty weak salt solution. All right, so example 2, it says, what is the molarity of 3.5 liters of solution that contains 62.5 kilograms? All right, so we know that we have 3.5 liters of a solution. We don't know what the solution is. So again, we're going to assume that we're making this in water. And it tells us that we are adding 62.5 grams of a salt. So this time it's potassium chloride. So we know that this is going to be our solute. Okay, because it doesn't give us the other solution or the other part of the solution. So again, we assume water. Well, we know water is always our solvent. All right, so if we remember, our formula is moles of solute over liters of our solution or liters of our solvent. Okay, so we're looking here. Well, we have an issue. Here it says we have 62.5 grams of potassium chloride. That does not match that unit, so we need to convert it so the unit does match. So we're just going to take our 62.5 grams potassium chloride, and we're just going to convert that using our picket fence to moles. So we know the molar mass is 74.55 grams per 1 mole. We just looked up the molar mass, and that'll give us, with sig figs, 8.38 moles of KCl. Now we can plug that into our equation, so we're just going to take that, and we know we just divide that over our liters of our solution. And since, again, it doesn't tell us what it is, we assume water. So we have to calculate it out. So we look here, pay attention to sig figs. So 3 sig figs, 3 sig figs. So we divide those out, and we end up getting, with the correct sig figs, 2.39. And again, you have two options of units. I'll use the other unit this time, 2 molarity of a KCl solution. So why don't you guys try example 3. So what mass of potassium hydroxide would be needed in order to prepare 1.5 liters of a 9.50 molarity solution? All right, so again, there are 2 different units of concentration. The next one's molality. Again, the same thing, except for this time, molality is represented by a lowercase m. So lowercase m's molarity is capital M. The only difference here is instead of our solvent being in liters, we do our solvent in kilograms. Still moles of solute, so our units are still moles, but now instead of moles per liter, our unit would be moles per kilogram. Again, the higher the molality, the stronger the solution is, or the more solute we have. Okay, so again, it's the exact same thing, just telling us the ratio of solute to solvent. So we'll try 2 examples together, and I'll have you guys try one on your own. All right, so it's asking what is the molarity of a solution that contains 18.2 grams of HCl and 250 grams of water. So it's a little tricky because it's asking for molality, and molality is moles of solutes over kilograms solvent. So we need to figure out which one's the solute and which one's the solvent. So remember, the solute is a thing being dissolved. The solvent's the thing doing the dissolving. Well, one of these is our universal solvent. Okay, it's not HCl, it's water. So water always is our solvent, which means that HCl must be our solute. So we know that the HCl has to be turned into moles, and the solvent has to be turned into kilograms in order to plug it into our equation. So the first thing we're going to do is we're going to take our 18.2 grams of HCl of our solute and turn that into our correct unit. All right, so again, we have 18.2 grams turned into moles. We use our molar mass. Pay attention to sig figs. It'd be 3 sig figs. That gives us 0.49 moles of HCl. All right, so our solute is in the correct unit. Now we need to look at our solvent. Solvent needs to be in kilograms. Well, we know for every 1,000 grams, there's 1 kilogram. So 250.0 grams is the same thing as 0.2500 kilograms. So now we can plug that into our equation. So I'm going to divide moles by kilograms. Looking at sig figs, we have 3 sig figs here, 4 sig figs here, meaning our answer can only have 3. We calculate that out, and we end up getting a molality 2.00, because we can only have 3 sig figs. You have 2 options for units, moles of HCl over kilograms, or you could have just written a lowercase m. And that would be our answer. Okay, so example 5, so we'll try one more together, and then I'll have you guys try one on your own. So it asks how many grams of silver nitrates, so grams of silver nitrate, are needed to prepare a 0.25 molality, we know it's molality because it's lowercase m, solution in 250 milliliters of water. So we see water again, so we know This 250 milliliters is in terms of our solvent. Okay, so we're using our molality equation because it says little m, so lowercase m molality, and then we're going to do, so we know kilograms of solvent. So we're going to get our information. Okay, so that means that silver nitrate is our solute. So we're going to first plug in our information. So we know that m is going to be 0.125. All right, and then we know that we're given information on our solvent, our water. So we know we're given 250.0 milliliters. Well, we need that in kilograms. So we need to remember the density of water is 1 gram per milliliter. So we can cross out milliliter and replace it with grams. So 250 milliliters is the exact same thing as 250 grams. Still not in the correct unit, but now we know we can just divide that by 1,000. And that would give us 0.2500 kilograms. So we can plug that in. And this is of our water, which means that our X is our moles of solute. So we look at sig fig, so we have 4, 3. So our answer is going to have 3. So that would give us moles of our solute, which is silver nitrate. Okay, that's still not correct because it's asking grams. All we do then is multiply this by our molar mass. And that would give us our final answer, which would be 5.30, because of sig figs, we have 3 sig figs there, grams of AgNO3. And that would be our final answer. All right, so why don't you guys try example 6? So go through and calculate it. It's asking, so molal, just a heads up, is the same thing as molality.